Hello there and welcome back to Science After Hours. Tonight, we are going to step out of the warmth and into the hushed, blue-gray world of winter. We are going to explore a substance that transforms the landscape, silencing the noise of the modern world and covering the earth in a blanket of quiet purity. We are talking, of course, about snow. It is a material that is both incredibly common and endlessly complex. It begins high in the atmosphere as a microscopic dance of molecules and ends as the vast white fields that define our winters. It is ephemeral, disappearing with the touch of a warm hand, yet powerful enough to carve mountains and stop civilizations in their tracks. If you enjoy these gentle journeys into the natural world, you can like and subscribe, or simply share a thought down in the comments. It helps others find their way here too. One sleepy soul at a time. But for now, settle in, pull the blanket up a little higher, and imagine the soft, rhythmic tapping of flakes against the window pane. Allow yourself to drift as we explore the silence of snow. Let's begin. Snow is not actually white. We look at a winter field and see a blinding expanse of white, but this is an illusion of light. If you were to isolate a single snowflake and look at it under a microscope, you would see that it is made of clear, transparent ice. It is as see-through as a pane of glass. So why does the snowbank look white? It is due to the physics of optics. Each individual snowflake acts like a tiny complex prism with countless facets and edges. When sunlight hits a pile of snow, it doesn't pass straight through. Instead, it is scattered, bounced, and reflected in every possible direction by the millions of tiny ice crystals. Because the ice reflects the full spectrum of visible light equally, our eyes perceive the result as the color white. Imagine a pile of crushed diamonds or broken glass. The material is clear, but the pile shines white. Snow is a landscape of millions of tiny transparent jewels scattering the light of the sun to create the brightest substance in nature. Every snowflake needs a speck of dust. A snowflake cannot be born from nothing. Pure water vapor, even at freezing temperatures, has a hard time turning into ice on its own. To make the transition from gas to solid, the water molecules need something to grab onto, a foundation to build upon. This is called a nucleus. At the heart of every beautiful crystalline star falling from the sky lies a tiny, invisible imperfection. It might be a speck of dust from a desert thousands of miles away, a grain of pollen from a flower, a particle of volcanic ash, or even a microscopic bit of bacteria. Imagine the journey of a single piece of dust floating in the upper atmosphere, lonely and drifting. Suddenly, it becomes the anchor for water vapor, which freezes onto its surface. Layer by layer, the crystal builds outward from this dirty center. It is a beautiful metaphor. At the core of every perfect, pristine snowflake is a tiny piece of the earth that made it possible. Physics demands 6 sides. You have likely heard that snowflakes are hexagonal, but have you ever wondered why you never see a square or a pentagonal snowflake? It comes down to the chemistry of the water molecule itself. Water is made of 1 oxygen atom and 2 hydrogen atoms, H2O. When water freezes, the molecules arrange themselves into a rigid lattice structure to maximize the strength of their hydrogen bonds. The most efficient, stable angle for these bonds to form is roughly 120 degrees. When you repeat this connection over and over, billions of times, the geometry scales up. The microscopic hexagon of the molecular lattice becomes the macroscopic hexagon of the snowflake. Imagine a builder who only has bricks of a certain shape. No matter how large the castle gets, the fundamental geometry is dictated by the shape of the brick. The laws of physics act as the architect, strictly enforcing the rule of 6, ensuring that every snowstorm is a parade of hexagons. Wilson Bentley captured the first flake. For most of human history, the structure of a snowflake was a fleeting mystery. It melted as soon as it landed, vanishing before it could be studied. That changed in 1885 with a farmer from Vermont named Wilson Snowflake Bentley. Bentley was not a trained scientist, but he was obsessed with the beauty of snow. He attached a microscope to a large bellows camera and spent winters standing in the freezing cold of his woodshed, catching falling flakes on black velvet. He had to hold his breath so his warmth wouldn't melt his subjects. After years of trial and error, he captured the first clear photograph of a single snowflake. Imagine the patience required, standing in the biting cold for hours, hunting for the perfect crystal, racing against the melt. He revealed to the world that these tiny miracles of beauty, as he called them, were intricate masterpieces of geometry. He showed us that the storm was not just a mass of cold, but a gallery of art. Snow is a silencer. One of the most magical qualities of a snowfall is the silence that descends with it. This is not just poetic, it is acoustic science. Freshly fallen snow is highly porous. It is not a solid block of ice, but a fluffy lattice filled with air pockets. These gaps between the ice crystals act like the acoustic foam tiles in a recording studio. When sound waves, the roar of a car, the chirp of a bird, the footsteps of a person hit the snow, they enter these air pockets and bounce around until their energy is absorbed. A blanket of fresh snow can dampen ambient noise by as much as 60%. Imagine walking through a city after a heavy blizzard. The usual hum of traffic and industry is gone, swallowed by the ground. The world feels intimate and hushed, as if the volume knob of reality has been turned down to a whisper. Snow is 95% air. We tend to think of snow as frozen water, but it would be more accurate to call it frozen air. Fresh, fluffy powder snow is composed of 90% to 95% trapped air and only 5% to 10% actual ice material. This is why it is so light to shovel when it first falls, and why it drifts so easily in the wind. This high air content is also what makes snow such an incredible insulator. The air trapped between the crystals cannot circulate, which stops the transfer of heat. Imagine the snow as a down comforter made of ice. It creates a barrier between the freezing air above and the ground below. This is why animals burrow into the snow to survive. The temperature inside a snowbank is often much warmer than the biting wind outside. The snow is not just a cold covering. It is a blanket of air that keeps the life of the soil safe through the winter. Thundersnow is a rare collision. Usually, thunder and lightning are reserved for the heat of summer storms. But occasionally, when the atmospheric conditions are just right, we witness the rare and dramatic phenomenon of thundersnow. This occurs when a strong cold front collides with warm air, creating unstable vertical currents, just like in a summer thunderstorm. However, the acoustics are different. In a rainstorm, thunder can be heard for miles. In a snowstorm, The falling snow dampens the sound waves. The thunder in a snowstorm doesn't roll or rumble. It sounds like a muffled, loud thump or a crack that is heard only within a mile or two of the lightning strike. Imagine standing in a whiteout blizzard, the world gray and blurry, when suddenly the sky lights up with a purple flash followed by a muted boom. It is a surreal clash of seasons, a moment where the energy of summer invades the quiet of winter. Snowflakes fall at a leisurely pace. Raindrops are aerodynamic. They streak down from the clouds at speeds of up to 20 miles per hour. Snowflakes, however, are like parachutes. Their broad, flat, intricate shapes create immense drag against the air. The average snowflake drifts down at a gentle speed of 1 to 4 miles per hour. It is a slow-motion descent. Imagine walking at a casual stroll. You are moving faster than the snow falling around you. This slow speed is what allows us to watch individual flakes, to track their path as they dance and swirl in the wind. It takes a long time for a snowflake to travel from the cloud to the earth, sometimes an hour or more. It is a journey of drifting, a gentle settling rather than a plummet. The largest snowflake was a monster. We usually imagine snowflakes as tiny specks, perhaps the size of a coin at most, but under specific conditions, they can grow massive. The Guinness World Record for the largest snowflake was reported in Fort Keogh, Montana in 1887. Ranchers described flakes that were larger than milk pans, measuring 15 inches wide and 8 inches thick. How is this physically possible? These were likely not single crystals, but aggregates. Hundreds of snowflakes that collided and clumped together as they fell through wet, sticky air. Imagine a frisbee made of lace falling from the sky. While we haven't seen 1 5-inch flakes recently, it is common to see clumps the size of baseballs in heavy, wet spring snows. It reminds us that snow is sticky. It wants to connect, to build larger structures out of its tiny parts. Mars has cubic snow. Snow is not unique to Earth, but on other planets, it takes on alien forms. On Mars, it gets cold enough for carbon dioxide, the gas we exhale, to freeze solid. This is dry ice. The Mars Reconnaissance Orbiter has detected carbon dioxide snow clouds on the red planet. But because the molecular structure of CO2 is different from H2O, Martian snowflakes are not six-sided stars. Computer models suggest they are microscopic cubes. Imagine standing on the rusty red surface of Mars, looking up at a pinkish sky, and watching tiny, white, square sugar cubes falling gently to the ground. It is a familiar weather pattern, twisted by alien chemistry. It snows on Mars, but it is a dry, cubic, frozen gas. A snowstorm for robots, not for snowmen. The magic temperature is not freezing. We assume that the colder it is, the more it snows. But actually, the heaviest snowfalls happen when the air is relatively warm, just slightly above or below 32 degrees Fahrenheit, 0 degrees Celsius. Warm air can hold more moisture than cold air. When it is incredibly cold, say 10 degrees below zero, the air is often too dry to produce big, fluffy flakes. Instead, you get diamond dust, tiny, gritty crystals. The perfect snowstorm requires a balance, cold enough to freeze, but warm enough to provide the water vapor needed to build the crystals. Imagine the atmosphere as a kitchen. You need ingredients to bake a cake. If the kitchen is too cold, the ingredients, water vapor, disappear. The biggest, fluffiest flakes are born on the edge of the melt in the warmest breath of winter. Geonophobia is the fear of snow. For most, snow brings a sense of wonder or perhaps annoyance at the commute. But for some, it triggers a deep, primal panic. Geonophobia is the extreme, irrational fear of snow. This fear often stems from the dangers associated with winter, being trapped, slipping on ice, or hypothermia. For a geonophobe, a weather forecast predicting flurries can induce severe anxiety. Imagine looking out the window and seeing the white flakes not as a blanket, but as a cage. The silence of the snow doesn't feel peaceful. It feels isolating. It reminds us that humans are tropical creatures by origin. We have learned to survive the cold, but the instinctual fear of the white death still lingers in our psychology. Snow blindness burns the eyes. Snow is the most reflective natural surface on Earth. While soil reflects about 10% of sunlight and green grass about 25%, fresh snow reflects up to 90% of the UV radiation that hits it. This creates a danger known as photokeratitis, or snow blindness. It is essentially a sunburn on the corneas of your eyes. It can happen even on a cloudy day. The Inuit people of the Arctic understood this danger thousands of years ago. They carved goggles out of bone or wood with narrow slits to limit the amount of light entering the eye. Imagine the world turned into a mirror, the light assaulting you from above and below. The snow doubles the sun. It is beautiful to look at, but without protection, its brilliance is blinding. Watermelon snow smells sweet. If you hike high into the alpine glaciers of the Sierra Nevada or the Rockies in summer, you might see patches of snow that look pink or red, as if someone spilled juice on them. If you step on it, it might even release a faint, sweet scent resembling watermelon. This is not a chemical spill, it is biology. Watermelon snow is caused by a microscopic algae called Chlamydomonas nivalis. These algae thrive in freezing water. They produce a bright red pigment to protect themselves from the intense UV radiation at high altitudes. Essentially, they are wearing sunscreen. Imagine a microscopic garden blooming in the ice. The red color absorbs heat, melting the snow slightly to provide the liquid water the algae needs to drink. It is life hacking the chemistry of winter to survive. Snow rollers are nature's donuts. Occasionally, after a snowstorm, you might wake up to find a field covered in what looks like rolled up sleeping bags or donuts made of snow. These are snow rollers. They are a rare meteorological phenomenon. They form when the snow is moist and sticky, the wind is strong, and the ground is sloped. A chunk of snow is blown by the wind, and it rolls, gathering more layers like a snowball. But unlike a snowball we make with our hands, these are hollow in the center because the inner layers are often blown away. Imagine the wind playing in the field, rolling hundreds of delicate hollow cylinders. They are fragile sculptures, crumbling at the slightest touch, created by the invisible hands of the breeze. Diamond dust sparkles near the ground. And the coldest places on Earth, Antarctica, the Arctic, or the deep interior of continents, you can experience precipitation even when there are no clouds. This is called diamond dust. It happens when the air is so cold that water vapor crystallizes directly near the ground. Tiny, Hexagonal ice prisms float in the air, sparkling like glitter in the sunlight. Imagine walking through a shimmering fog. The sky is blue and clear, but the air around you is filled with millions of floating diamonds. It creates optical phenomena like sundogs and halos, turning the atmosphere into a glittering jewelry box. It is snow stripped of its complexity, reduced to its simplest, most sparkling form. Rime ice is a frozen instant. There is a difference between snow that falls from the sky and ice that grows on trees. Rime ice forms when supercooled water droplets in fog touch a surface, like a branch or a fence wire, and freeze instantly. Because they freeze on contact, they trap air inside, creating a white, opaque, feathery structure. Rime ice grows into the wind, building out in long, sharp needles. Imagine a mountaintop forest. After a freezing fog, every twig, every needle, every blade of grass is encased in thick white armor. The trees look like coral reefs bleached white. It is a frozen snapshot of the wind itself, capturing the direction of the breeze in solid ice. Glaciers are blue because they are dense. We learned that snow is white because of the air trapped inside. But if you compress snow for hundreds of years, burying it under tons of weight, the air is squeezed out. The ice crystals fuse together into a solid, dense mass. This is glacial ice. Without the air bubbles to scatter light, the ice begins to behave like water. It absorbs the red, orange, and yellow wavelengths of sunlight, but allows the blue wavelengths to pass through and scatter. Imagine standing at the foot of a glacier. The ice glowing from within is not white, but a deep, electric turquoise. It is the color of time. It is snow that has been crushed by the weight of history until it reveals its true blue nature. Eating snow has a cost. It is a childhood joy to catch snowflakes on your tongue or eat a handful of fresh powder. And while fresh snow is generally clean, mostly distilled water, eating it in a survival situation is dangerous. The danger isn't bacteria, it's thermodynamics. To turn snow into water your body can use, you must first melt it. This requires a huge amount of caloric energy. Eating snow lowers your core body temperature, accelerating hypothermia. Imagine your body as a furnace. Shoveling frozen ice into the furnace dampens the fire. In the wild, you must melt the snow before you drink it. It reminds us that snow is a heat sink, a substance that craves warmth and will steal it from you if you are not careful. Physics forbids the number 5. We return to the geometry of the flake for our final fact of this section. Throughout history, artists have drawn snowflakes with 5 points or 8 points. But nature never does this. The atomic lattice of ice is strictly hexagonal. You can have 3-sided crystals, rare, 6-sided crystals, common, or 12-sided crystals, twinned. But a 5-sided snowflake, or an 8-sided one, is a physical impossibility on Earth. Imagine the strict laws of the universe governing even the tiniest speck of falling ice. No matter how chaotic the storm, no matter how wild the wind, the water molecules obey the rules. Every snowflake is a testament to the order underlying the chaos of nature, the Inuit, and their many words. There is a famous linguistic myth that the Inuit people have hundreds of words for snow. While linguists debate the exact number, the core truth is fascinating. In English, we might just say snow or slush. But In languages like Inuktitut and Yupik, the vocabulary is far more precise because survival depends on it. They have distinct root words for snow on the ground, aput, falling snow, kana, drifting snow, peekserpok, and snow that is good for igloo building. Imagine living in a world where the white landscape is so vital that you need a specific word for fine snow blown by the wind. It reminds us that we name what we notice. To a person living in the Arctic, snow is not just one thing. It is 1,000 different materials, each with its own texture, danger, and use. A blizzard is defined by the wind. We often use the word blizzard to describe any heavy snowfall, but meteorologically, a storm can drop 2 feet of snow and not be a blizzard. Conversely, a storm can drop 0 inches of new snow and still be a blizzard. The definition relies on wind and visibility. To qualify, the wind must be blowing over 35 miles per hour and visibility must be reduced to less than 1/4 of a mile for at least 3 hours. This is often caused by ground blizzards, where old snow is picked up and whipped around by the wind. Imagine standing in a white void where the sky and the ground merge. You cannot see your hand in front of your face. It is a storm of disorientation where the danger comes not from the falling flakes, but from the blinding, howling air. Snow covers 1/4 of the earth. Even though many of us live in places that rarely see winter, snow is a massive part of our planet's identity. At the peak of the northern winter, snow covers about 46 million square kilometers, roughly 23% of the Earth's total land surface. Imagine looking at the Earth from space in January. The top cap of the planet is draped in white, stretching down through Canada, Russia, Scandinavia, and the northern United States. This white blanket reflects sunlight, helping to cool the entire planet. It acts as a global air conditioner. The snow is not just a local weather event. It is a continental shield that regulates the temperature of the world. Monkeys make snowballs for fun. In the Jigokudani Monkey Park in Japan, there lives a famous troop of Japanese macaques, also known as snow monkeys. These intelligent primates have adapted to the cold in remarkable ways, famously bathing in natural hot springs to stay warm. But researchers have observed something even more charming. The young monkeys play with snow. They have been seen gathering snow, packing it into balls, and rolling them around or carrying them, not for food, not for shelter, but purely for fun. Imagine a small monkey sitting in the steam of a hot spring, holding a snowball. It suggests that the joy of packing fresh, sticky snow into a sphere is not uniquely human. It is a tactile pleasure shared by our distant cousins. Graupel is styrofoam snow. Sometimes precipitation falls that looks like tiny white balls, but it isn't hail and it isn't quite snow. This is graupel. It forms when supercooled water droplets coat a falling snowflake, freezing instantly and turning the delicate crystal into a round rime-covered pellet. If you squeeze graupel, it crumbles like polystyrene or styrofoam. It is soft and airy, unlike the hard ice of hail. Imagine a storm dropping millions of tiny beanbag chair fillers. When graupel falls on a mountain, it acts like ball bearings. It creates an unstable layer that can easily slide, making it a notorious cause of avalanches. It is a wolf in sheep's clothing, soft to the touch, but dangerous in a pile. Artificial snow is made with air cannons. If nature doesn't provide snow for ski resorts, humans intervene. But we don't freeze ice cubes and shave them. That would be too slow. Instead, snow guns mimic the cloud. They pump high-pressure water and compressed air out of a nozzle, misting the water into tiny droplets. As the droplets shoot into the cold air, the compressed air expands and cools rapidly, freezing the water before it hits the ground. Imagine a machine that breathes winter. The snow it makes is different from natural snow. It is denser, more like tiny frozen beads than fluffy stars. It is durable and fast, a marvel of engineering that allows us to ski when the sky refuses to cooperate. Temperature dictates the shape. Why do some snowflakes look like stars and others like needles? It depends entirely on the temperature and humidity of the cloud they fall through. It is a predictable map of growth. At just below freezing, 32 degrees Fahrenheit to 25 degrees Fahrenheit, you get flat plates. A little colder, 25 degrees Fahrenheit to 15 degrees Fahrenheit, and you get long needles or columns. At the sweet spot, 10 degrees Fahrenheit to 3 degrees Fahrenheit, you get the classic large six-armed stars, dendrites. Below that, it goes back to plates and columns. Imagine the snowflake falling through different layers of air, like a traveler passing through different countries. In one layer, it grows arms. In the next, it grows flat. Its final shape is a history record of its journey through the sky. Stellar dendrites are the stars. The most iconic snowflake, the one you see on holiday sweaters and decorations, is scientifically called a stellar dendrite. Stellar means star-like, and dendrite means tree-like. These form in high humidity clouds where there is plenty of water vapor to grab. The crystal grows branches, and those branches grow smaller side branches. Imagine a microscopic fern unfurling in 6 directions at once. These large branching arms are what allow snowflakes to lock together when they land, creating the fluffy, packing snow perfect for snowballs. They are the Velcro of the winter world. Needle crystals are sharp. Not all snow is soft. At certain temperatures, snow crystals grow as long, thin splinters called needles. They look like tiny shards of white hair or pencil shavings. Because they are long and thin, they don't pack together well. They slide past each other. Imagine a snowfall that looks like white rain piling up in a dense, shifting heap. If you look closely at your dark coat sleeve during a storm, you might see these tiny, singular rods instead of stars. It is a minimalist snowflake, stripped of its branches, simple and sharp. Capped columns look like wheels. One of the strangest snowflake shapes is the capped column. It starts its life as a column, a tiny hexagonal tube of ice. But then, it falls into a different temperature zone that favors plate growth. So, it grows 2 flat plates on either end of the tube. Imagine 2 wheels connected by an axle, or an empty spool of thread made of ice. These are rarely noticed by the naked eye because they are small, but under a microscope, they are architectural marvels. They prove that a snowflake can change its mind halfway down, switching from a tube to a plate as the weather dictates. Avalanches travel at race car speeds. An avalanche is a terrifying display of potential energy turning into kinetic energy. When a slab of snow breaks loose from a mountainside, it can accelerate to speeds of 80 miles per hour. Within 5 seconds, large powder avalanches can reach nearly 200 miles per hour. Imagine a white tsunami racing down the slope, moving faster than you can drive on the highway. The snow is pulverized into a fine powder that acts like a fluid, flowing around trees and rocks, or snapping them like toothpicks. It is a reminder that snow is heavy. A cubic meter of settled snow can weigh hundreds of pounds. When millions of tons of it decide to move at once, nothing can stand in its way. The Yeti is a Himalayan legend. The mystery of the abominable snowman, or Yeti, is tied deeply to the snows of the Himalayas. For centuries, the Sherpa people have told stories of a large, bipedal creature wandering the high glaciers. While scientific evidence suggests that Yeti footprints are likely tracks made by bears that have melted and distorted in the sun, the legend persists. Imagine being alone on a high, snowy pass, the wind howling. You see a shape moving in the whiteout. The snow blurs reality, making bears look like men and rocks look like monsters. Snow fleas jump on the ice. If you look closely at the snow around the base of a tree on a mild winter day, you might see what looks like sprinkled pepper moving around. These are snow fleas, Pipogestra nivicola. They are not actually fleas, but springtails. They produce a special protein that acts as an antifreeze, allowing them to survive in sub-zero temperatures. Imagine a bug so tough it thrives on ice. They use a forked tail tucked under their belly to launch themselves into the air. They are the microscopic acrobats of the winter, proving that even the freezing snow is a habitat for life if you have the right chemistry. Snow can disappear without melting. Sometimes a snowbank shrinks even when the temperature never goes above freezing. This is due to a process called sublimation. Under the right conditions, lots of sunlight, dry wind, and low humidity, ice can turn directly into water vapor, skipping the liquid phase entirely. Imagine the snow ghosting away into the air. It simply vanishes. This is common on high mountain peaks like Mount Everest, where the air is thin and dry. The mountain doesn't just melt, it evaporates. It is a silent, invisible disappearance, the ice returning to the sky without ever wetting the ground. A white Christmas is strictly defined. We dream of a white Christmas, but meteorologists have strict rules for it. In the United States, a white Christmas is defined as having at least 1 inch of snow on the ground at 7 a.m. on December 25th. It doesn't actually have to snow on Christmas Day. The old snow counts. In the UK, the definition is stricter or looser, depending on how you see it. A single snowflake must be observed falling within the 24 hours of December 25th. Imagine a bookie watching the sky for one flake. The probability varies wildly. In Minnesota, it is almost a guarantee. In London, it is a rare treat. It reminds us how much we attach our cultural joy to the whims of the weather. Fresh snow reflects 90% of sunlight. We call this reflectivity albedo. Fresh, clean snow has the highest albedo of any natural surface, bouncing up to 90% of the sun's energy back into space. This creates a feedback loop. The snow reflects the sun, which keeps the ground cold, which helps the snow stay frozen, which reflects more sun. Imagine the polar ice caps as giant mirrors shielding the earth from heat. When the snow melts and reveals the dark soil or ocean beneath, the albedo drops, the heat is absorbed, and the warming accelerates. The whiteness of the snow is a shield, protecting the climate balance of the entire globe. In 1992, the city of Syracuse, New York, famous for its brutal winters, passed a tongue-in-cheek decree. The city council officially declared that any more snow falling before Christmas Eve was illegal. Imagine the politicians standing in the town hall, commanding the sky to stop. Nature, of course, did not listen. It snowed 2 days later. It is a humorous reminder of humanity's helplessness against the weather. We can build cities, split atoms, and fly to the moon, but we cannot stop a single snowflake from falling. We must simply shovel it. Igloos are warm inside. The Inuit igloo is a masterpiece of engineering, using snow's insulating properties. Even if it is minus 40 degrees Fahrenheit outside, the temperature inside an igloo occupied by people and a small oil lamp can rise to 60 degrees Fahrenheit. That is a 100-degree difference created solely by walls of packed snow. The body heat melts the inner layer of the walls slightly, which then refreezes into a sheet of ice, sealing the wind out. Imagine sitting comfortably in your shirt sleeves inside a dome of snow while a blizzard rages inches away on the other side of the wall. The snow traps your own warmth and gives it back to you. Cities melt snow faster. Snow in the city is different from snow in the country. It is darker, grittier, and it disappears faster. This is due to the urban heat island effect. Concrete, asphalt, and buildings hold on to heat long after the sun goes down. Additionally, city snow gets dirty. Soot and exhaust settle on the white drifts, darkening them. As we learned, dark colors absorb heat. Imagine a dirty snowbank eating itself. The soot acts like a solar panel, absorbing the sun and melting the snow from the top down. City snow is a victim of the city's energy. It cannot survive the heat of human industry. Penitentes are snow spikes. In the high, dry Andes Mountains, you can find fields of strange, jagged snow formations called penitentes. They look like thousands of white monks kneeling in prayer, or tall blades of ice pointing toward the sun. Some can be taller than a human. They form when the sun turns snow directly into vapor. Sublimation. In uneven pockets, the deep pits concentrate the sunlight, digging deeper, while the peaks remain frozen. Imagine a field of ice daggers. It is an alien landscape created by the specific physics of high-altitude light. It shows us that snow doesn't always lie flat. Sometimes it stands up and points at the sky. A snowstorm is heavy. We think of snow as light and fluffy, drifting on the breeze. But cumulatively, a storm is an event of staggering weight. A single, moderate snowstorm covering a large state can drop 39 million tons of water weight in the form of ice crystals. Imagine the sky carrying that burden. It is the equivalent of dropping a concrete skyscraper's worth of weight spread gently over the hills and roofs. This immense mass is why roofs collapse and tree limbs snap. The snowflake is gentle, but the snowstorm is a crushing force. It reminds us of the power of accumulation. One flake is nothing. A trillion flakes can sink a ship or flatten a forest. Snow is a protective blanket. Gardeners and farmers often welcome a deep layer of snow before the bitter cold of January sets in. Why? Because snow acts as a thermal blanket for the earth. Without snow, the sub-zero air would freeze the soil deep down, killing the roots of plants and hibernating insects. But under a foot of snow, the soil temperature remains steady, often hovering right around freezing, even if the air above is 20 below zero. Imagine the small creatures, mice, voles, beetles scurrying in the subnivean zone, the crawl space between the ground and the snowpack. To them, the snow is a roof. It protects life from the killing wind. It is a strange paradox. The frozen water keeps the world warm enough to live. The snowball Earth. Geologists have found evidence suggesting that around 650 million years ago, the entire planet Earth was covered in ice, from the poles all the way to the equator. This theory is called Snowball Earth. Imagine our blue and green marble turned completely white. The oceans were frozen over. The continents were buried. It would have looked like Enceladus or Europa, a dead white ball floating in space. Life barely hung on in small pockets of open water near volcanoes. It was the ultimate winter. The fact that the Earth thawed out, likely due to massive volcanic CO2 emissions, is the reason we are here today. We are the children of the Great Thaw. Dirty snow melts faster. If you have ever seen a pile of snow in a parking lot in March, you know it looks gray and gritty. This dirt is the architect of its own destruction. White snow reflects the sun, staying cool. But dark dirt absorbs the sun, heating up. This heat transfers to the snow, melting it. This creates a feedback loop. As the snow melts, the dirt concentrates on the surface, making it darker, absorbing more heat, and melting faster. Imagine the dirt particles boring into the ice like tiny hot coals. This principle is affecting the Greenland ice sheet today. Soot from wildfires and pollution is darkening the ice, causing it to melt faster than climate models predicted. The color of the snow dictates its lifespan. It snowed in Baghdad. Baghdad, Iraq, is one of the hottest cities in the world. It is a place of palm trees and desert dust. But in January 2008, something miraculous happened. For the first time in living memory, soft, wet flakes fell from the sky. Imagine the residents walking out into the streets, amazed, catching the melting flakes on their hands. For a brief, fleeting morning, the desert city was dusted in white. The snow melted quickly, but the memory remained. It serves as a reminder that the weather is a chaotic system. Even in the land of heat, the atmosphere can twist and turn just enough to bring a touch of the Arctic to the desert. Icicles are a cycle of freezing. The icicle is the quintessential decoration of winter, hanging like a crystal dagger from the roof. But its formation is a delicate dance between melting and freezing. To get an icicle, you need the roof to be warm enough to melt the snow, usually from escaping house heat or sunlight, but the air to be cold enough to freeze the drip. Imagine a single drop of water running down the ice. It reaches the tip, hangs for a second, and freezes. The icicle grows not from the top, but from the bottom, layer by layer, drop by drop. It is a vertical record of the temperature. A clear icicle means it froze slowly without bubbles. A milky one means it froze fast. It is a stalactite made of pure winter. Cornices are deadly overhangs. On the sharp ridges of high mountains, the wind blows snow over the edge, but instead of falling, the snow sticks together, building out horizontally into space. This forms a cornice, a cantilevered shelf of snow that hangs over a cliff like a frozen wave. Imagine standing on a mountain peak, thinking you are on solid ground. In reality, you are standing on a cornice, suspended over thousands of feet of empty air. These structures are notoriously unstable. They can break without warning, triggering massive avalanches. They are beautiful, curved, smooth, defying gravity. But they are a trap. They remind mountaineers that in the high country, the ground itself can be a deception. Sastrugi are waves of snow. When strong winds blow over hard-packed snow for days on end, they carve the surface into sharp, wave-like ridges called sastrugi. They look like sand dunes frozen in time, or the white caps of a choppy sea turned to stone. These ridges are hard as concrete. Imagine trying to ski or sled over them. It would rattle your teeth. Polar explorers hate sastrugi because they are brutal to pull a sled over. The wind acts as a sculptor, eroding the soft snow and leaving the hard, wind-packed ice behind in aerodynamic shapes. It turns the flat plain into a jagged ocean of white. Snowshoes mimic the hair. Humans are heavy. When we step on deep snow, we sink or post hole. This is exhausting. To solve this, ancient people looked to nature. They noticed that the snowshoe hare, despite being a decent size, hopped lightly on top of the drifts. The hare has enormous hind feet that spread its weight over a large surface area. By building wooden frames laced with rawhide, snowshoes, humans mimicked this biology. Imagine strapping tennis rackets to your feet to float on the powder. It is a perfect example of biomimicry. By artificially increasing the size of our footprint, we can walk on water. Frozen water, that is, just like the rabbit. The Olympics rely on fake snow. Climate change is altering the Winter Olympics. Since the 1980 Lake Placid Games, organizers have used artificial snow to supplement nature. But in recent years, it has become the main event. In the 2022 Beijing Olympics, almost 100% of the snow was artificial. Imagine a ribbon of white winding through a brown, dry landscape. This man-made snow is harder and icier than natural snow, making the ski slopes faster and more dangerous. It changes the sport. Athletes have to adapt to a surface that is consistent and predictable, unlike the wild variability of natural storms. It is a sign of a warming world. We are building winter where it no longer exists. Sneeze is a weather term. In the dialect of meteorology and local slang, particularly in the UK, when rain and snow fall together, it isn't quite slush and it isn't quite hail. It is snain, or affectionately, a sneeze. It captures that miserable transition zone where the air is damp and hovering right at 33 degrees. Imagine walking outside and getting hit by wet, slushy clumps that soak you instantly. It lacks the romance of snow and the cleansing feel of rain. It is the messy middle child of winter precipitation, cold and indecisive. Dry snow is fluffy. Meteorologists talk about the snow-to-water ratio. If you melt 10 inches of average snow, you get about 1 inch of water. But in very cold places like Utah or the Rockies, you get dry snow or champagne powder. Here, the ratio can be 30:1. Imagine snow so light you can blow it away with a breath. You could shovel a mountain of it and barely break a sweat. It is mostly air. This is the dream of skiers, floating through clouds of white smoke. It forms when the temperature is well below freezing, preventing the flakes from sticking together, keeping them distinct and airy. Wet snow is heavy. On the coast or in early spring, we get wet snow or Sierra cement. The temperature is near freezing and the flakes are partially melted and sticky. the ratio drops to 5:1 or 8:1. Imagine trying to shovel this. It comes up in heavy, solid slabs. It sticks to the shovel. It breaks your back. This is the snow that brings down power lines and snaps trees because it clings to everything it touches. It is excellent for snowballs and snowmen because it packs tight, but it is a nightmare to move. It is water that hasn't quite decided to be ice. Crevasses are hidden traps. On a glacier, the ice cracks as it flows over uneven ground. These cracks, or crevasses, can be hundreds of feet deep, but in winter, snow blows over the top, forming a snow bridge. Imagine a thin arch of snow hiding a bottomless blue chasm. To the hiker, the surface looks like a smooth, unbroken white field. One wrong step, and the bridge collapses. Mountaineers travel roped together for this very reason. It reminds us that snow is a concealer. It hides the brokenness of the world, smoothing over the cracks with a beautiful, deadly lie. Snow mold attacks the grass. When the snow finally melts in spring, you might find patches of your lawn covered in a pink or gray fuzz. This is snow mold, a fungus that thrives under the snow cover. While the grass was dormant and covered, the fungus had a feast in the cool, moist environment. Imagine a microscopic world thriving in the dark, under the ice. It is a reminder that life doesn't stop in winter, it just changes strategies. Even under the blanket of the dead season, something is eating, growing, and waiting for the sun. Antarctica is a desert. We think of deserts as hot and sandy, but the scientific definition of a desert is purely about precipitation. A desert receives less than 10 inches of water a year. By this metric, Antarctica is the largest desert on Earth. In the deep interior, it almost never snows. The air is too cold to hold moisture. The ice that is there has accumulated over millions of years, not from heavy storms, but from light frost and the occasional dusting that never melts. Imagine a place of infinite white that is actually drier than the Sahara. It is a frozen drought. The sound of snow is a squeak. We mentioned that snow absorbs sound, but it also makes a sound. When you walk on snow that is warmer than 14 degrees Fahrenheit, minus 10 degrees Celsius, the pressure of your boot melts the crystals slightly, lubricating them. The snow packs silently. But when the temperature drops below 14 degrees Fahrenheit, the pressure isn't enough to melt the ice. The crystals snap and break against each other. Imagine walking on a bitter cold night. Squeak, squeak, squeak. That high-pitched crunch is the sound of ice friction. It is the audible signal of deep cold. If your boots are squeaking, you know you need to cover your ears. Fern is old snow. Snow doesn't stay snow forever. If it survives the summer without melting, it gets buried by the next winter's snow. Over time, the snowflakes lose their points and become rounded grains of ice. This is called fern, or neve. It looks like wet sugar. Imagine digging into a glacier and finding this granular, corn-like ice. It is the intermediate stage, the teenager phase, between the fluffy snowflake and the solid blue glacial ice. It takes years, sometimes decades, for snow to become fern and decades more to become glacier. It is snow in the process of fossilizing. The ptarmigan disappears. Most animals simply hide from the snow, but the ptarmigan embraces it. This bird changes its feathers from speckled brown in summer to pure, brilliant white in winter. It even grows feathers on its feet to act as snowshoes. Imagine a bird so perfectly camouflaged that you could look right at a snowbank and not see it until it blinks. It becomes a ghost. It survives by becoming the landscape. It reminds us that nature rewards adaptation. If you cannot fight the winter, you must join it. Snow fences build drifts. If you drive through the open plains of Wyoming or the Dakotas, you will see rows of wooden slat fences standing alone in the fields, far from any road. These are snow fences. They are not there to stop the wind. They are there to confuse it. When the wind hits the fence, it slows down. Slow air drops its snow. Imagine the fence forcing the storm to dump its load of snow in the field, creating a massive drift behind the wood slats rather than on the highway 100 yards away. It is a clever trick of aerodynamics. We use the wind to plow the snow for us, stacking it neatly out of the way. Salt fights ice with chemistry. When winter roads turn treacherous, we scatter rock salt. But how does a simple crystal melt ice? It isn't heat, it's chemistry. Salt creates a solution with the thin layer of water on top of the ice, which lowers the freezing point of the water. Pure water freezes at 32 degrees Fahrenheit, but salty water can stay liquid down to 15 degrees Fahrenheit or lower. Imagine the salt crystals waging a microscopic war, forcing the ice molecules apart, preventing them from locking into their rigid crystal lattice. The road becomes wet, but not icy. It is a victory of solubility over structure. However, it only works to a point. If it gets too cold, even the salt gives up and the ice returns. Beet juice is the new road salt. Salt is effective, but it rusts cars and hurts plants. So, engineers have found a surprising alternative. Beet juice. The sugary purple runoff from sugar beet processing is sticky and lowers the freezing point of water even better than salt alone. Imagine a highway sprayed with a faint purple tint. The sugar molecules interfere with ice formation, effectively confusing the water so it cannot freeze. It is also biodegradable. We are essentially marinating our roads to keep them safe. Other places use cheese brine, in Wisconsin, or pickle juice. It shows that the solution to a harsh winter often lies in the leftovers of our own kitchens. The snow eater wind. In the Rockies, there is a legendary wind called the Chinook, or the snow eater. It is a warm, dry wind that blows down the eastern slopes of the mountains. It can raise the temperature by 40 degrees in a single hour. This wind is so dry that it doesn't just melt the snow, it vaporizes it. Residents have reported waking up to a foot of snow and going to bed with green grass. Imagine a wind that acts like a hairdryer on a continental scale. It is a violent, sudden end to winter, devouring the snowpack in a single afternoon. Aomori is the snowiest city. If you hate shoveling, do not move to Aomori City, Japan. Located in the northern mountains, it is officially the snowiest city on Earth. It receives an average of 26 feet, 312 inches of snow every year. This happens because cold winds from Siberia pick up moisture as they cross the Sea of Japan and dump it all on the mountains around the city. Imagine living in a place where the snowbanks are taller than buses. The roads become white canyons with walls of ice towering 20 feet high on either side. It is a city that lives in a tunnel of winter for half the year, adapting its entire existence to the endless falling white, Snowflakes clump into aggregates. We imagine single, perfect flakes falling, but in reality, they like to hold hands. As they fall, their arms interlock. This is called aggregation. It happens most often when the temperature is near freezing, making the crystal arms slightly wet and sticky. Imagine hundreds of tiny stars crashing into each other, tangling their limbs to form a giant, chaotic clump. These puffballs land soft and silent. It is nature's way of cleaning the sky quickly, sweeping millions of crystals down in a single package. Hoarfrost is not snow. Sometimes you wake up and the trees look like they have been dipped in sugar, even though it didn't snow. This is hoarfrost. It forms on clear, cold nights when water vapor in the air touches a sub-freezing object and turns directly into ice crystals. Unlike rime ice, which comes from fog, hoarfrost is delicate and feathery. Imagine a chain-link fence transformed into lace, or a blade of grass growing white fur. It is ephemeral beauty. The slightest breeze or the first touch of sun will destroy it. It is the ghost of the humidity, visible only for the quietest hours of the morning. Factories make industrial snow. In very cold, stagnant weather, the steam rising from factory smokestacks or power plants can create its own weather system. The water vapor rises, freezes, and falls right back down as snow. This is industrial snow. Imagine a clear day with blue skies everywhere, except for a single gray cloud hovering over a power plant, dusting the parking lot with white. It is a localized, man-made microclimate. It is a reminder that we are constantly interacting with the atmosphere. Our waste heat and steam can accidentally mimic the forces of nature. Lake effect snow buries the coast. People living near the Great Lakes know the fury of lake effect snow. It happens when freezing cold wind moves over the relatively warm water of a lake. The air acts like a sponge, sucking up massive amounts of heat and moisture. When this heavy, wet air hits the land on the other side, it dumps its load. Imagine a conveyor belt of clouds forming over the water and unleashing a narrow, intense band of snow on one specific town, while the next town over sees sun. It can drop 5 feet of snow in a couple of days. It is the lake trying to give its heat to the land in the form of ice. Bacteria make snow for skiing. We talked about snow guns, but there is a secret ingredient in the water, Pseudomonas syringae. This is a common bacterium found on plants. It has a special protein on its cell wall that mimics the structure of an ice crystal. Water loves to freeze onto this protein. By adding dead, sterilized bacteria to the water in snow guns, resorts can make snow at warmer temperatures. Imagine billions of microscopic bacteria acting as the seeds for the slopes. It is biotechnology meeting winter sports. We are using the architecture of a cell to trick water into freezing. Sunglasses were invented for snow. Long before Ray-Bans, the Inuit created the first sunglasses to fight snow blindness. They carved goggles from caribou antler or driftwood. They didn't have glass lenses. Instead, they had narrow horizontal slits. These slits blocked out the blinding glare of the sun, reflecting off the ice, allowing only a thin strip of light to enter. Imagine viewing the world through a letterbox. It improved focus and protected the eyes. It is a piece of ancient technology that saved vision in a world made of mirrors. Yucca marmo are frost balls. On the high plateau of Antarctica, where the air is unimaginably cold, a rare phenomenon occurs. Tiny balls of frost form on the ice. They are light and tumble in the wind like tumbleweeds. They are called yukimarimo. snow marimo, named after the round algae balls found in Japan. Imagine a field of thousands of delicate white puffballs rolling endlessly across the flat blue ice. They clump together electrostatically. It is a playful form of ice that exists only at the bottom of the world, rolling alone in the dark. Deep snow is blue. If you poke a hole deep into a snowbank, the light inside glows blue. We learned this is because ice absorbs red light, but it is also a sign of purity. Only clean, deep snow shows this color. If the snow is dirty or thin, the light scatters too much. Imagine digging a snow cave. As you tunnel deeper, the white daylight fades into a soft, serene azure. It feels like being underwater. It is the true color of frozen water, revealed only when you are surrounded by it. Snow is a mineral. If you look up the scientific definition of a mineral, it must be 1. Naturally occurring, 2. Solid, 3. Inorganic, 4. Crystalline, and 5. Have a specific chemical composition. Ice fits all of these. Therefore, snow is technically a sediment made of minerals. A snowstorm is a sediment transport event. A glacier is a metamorphic rock, ice, compressed into new forms. Imagine a snowball fight as a mineral war. When you shovel the driveway, you are essentially mining. It changes our perspective. Snow is not just weather. It is part of the geology of the planet. Blood falls is rust. In Antarctica, a glacier named Taylor Glacier has a disturbing feature, a waterfall that bleeds. Deep red liquid flows out of the white ice. For years, it was a mystery. It turns out to be ancient salt water trapped beneath the glacier for millions of years. It is rich in iron. When it finally reaches the surface and touches the air, the iron oxidizes. It rusts instantly. Imagine a wound in the ice that never heals. It is a time capsule of water from a prehistoric ocean, released into the modern world as a flow of red brine. The biggest snowman was a giant. In 2008, the residents of Bethel, Maine, built Olympia, the world's largest snow woman. She stood 122 feet tall. That is taller than a 10-story building. They used cranes to pile the snow. Her eyes were wreaths, her eyelashes were skis, and her lips were painted car tires. Imagine a snowman so big, its shadow stretches across the town. It took months to melt. It serves as a testament to the human desire to play. Give us enough snow, and we will try to build a giant. Snow globes were a mistake. In 1900, an Austrian mechanic named Erwin Perzy was trying to improve the brightness of the newly invented electric light bulb. He tried filling a glass globe with water and metal flakes to reflect the light. The flakes sank too fast, so he tried semolina powder. It drifted down slowly, looking like snow. He abandoned the light bulb idea and put a miniature church inside instead. Imagine a failed experiment becoming a global souvenir. He accidentally captured the magic of winter in a glass sphere, creating a tiny contained world where the snow never stops falling. Blizzards sell cake. There is a strange psychological phenomenon that happens when a blizzard is forecast. People rush to the store, but they don't just buy bread and milk. Sales of cakes, cookies, and candy spike significantly. It is a coping mechanism. Faced with the prospect of being trapped inside, we crave comfort. We want to bake. We want sugar. Imagine a storm raging outside, wind shaking the walls, while inside the kitchen is warm and smells of baking brownies. The threat of the cold drives us to create our own internal warmth. Megadunes are frozen waves. In the heart of Antarctica, there are megadunes of snow that rival the sand dunes of the Sahara. But unlike sand dunes that move quickly, these snow dunes are ancient. The snow there is so hard and the accumulation so slow that a single dune might be centuries old. Imagine a wave of snow that has been frozen in mid-curl since the Middle Ages. It is a landscape of profound stillness, where the geography itself is made of slow-moving ice. Snow is a water tower. For billions of people, snow is life. The snowpack in the mountains acts as a frozen reservoir. It stores the water during the wet winter and releases it slowly during the dry summer as meltwater. Rivers like the Colorado, the Ganges, and the Yangtze depend on this cycle. Imagine the snowbank not as weather, but as a bank account. We save up the water in the winter to spend it in the summer. If the snow disappears due to climate change, the bank runs dry. The white peaks are the hydration of the world, waiting to be released. Frost quakes are loud booms. Sometimes, in the dead of winter, you might hear a loud boom in the middle of the night, like a cannon going off or a tree snapping. This is a cryosysm, or frost quake. It happens when water in the ground freezes and expands rapidly, cracking the soil or rock. Imagine the earth itself shivering so hard it cracks. It usually happens when the temperature drops quickly to sub-zero levels. It is the sound of the geology reacting to the cold, a geological gunshot in the silence of the winter night. The word avalanche means descent. Words have history, just like the snow. The term avalanche comes from the French word avalanche, which itself likely comes from the Latin labina, meaning landslide. But the older French root avalanche simply means downhill or descent. Imagine the terrified villagers in the Alps hundreds of years ago, needing a word for the white death that rushed down the mountain. The word captures the inevitability of gravity. Snow wants to go down. It piles up, fighting its own weight until the bond breaks and the descent begins. It is a word that sounds like a slide, a soft start followed by a rush. Snow preserves the past. Snow is an excellent medium for tracks. A footprint in mud might wash away in the rain, but a footprint in snow can last for weeks. If the temperature stays low, it freezes into a mold. Hunters and trackers read the snow like a newspaper. They can tell who walked there, how fast they were moving, and how long ago it happened by the sharpness of the edges. Imagine walking through the woods and seeing the story of the night before written in blue shadows on white paper. The path of a deer, the swoop of an owl's wingtips brushing the powder, the scamper of a mouse. The snow holds the memory of every movement until the melt wipes the slate clean. Skiing is 8,000 years old. We think of skiing as a modern sport with expensive gear and lift tickets, but humans have been sliding on snow for millennia. Ancient cave paintings in Russia and China date the invention of skiing back at least 8,000 years. These ancient skiers used long wooden planks and a single pole for balance. They weren't skiing for fun. They were hunting. Imagine a Neolithic hunter gliding silently over the deep drifts, moving faster than the elk he pursued. The ski was a tool of survival, a way to float on top of the winter instead of fighting through it. It turned the obstacle of snow into a highway. Spiders walk on snow. If you look closely at the snow surface on a mild winter day, you might see tiny spiders moving about. These are usually from the Linyphiidae family. Like snow fleas, they produce cryoprotectants, natural antifreeze, in their blood. Imagine a creature so delicate, with legs like thread, navigating a landscape of ice crystals that are giant boulders to them. They are hunting for dormant insects. It is a reminder that the cold does not kill everything. There is a microscopic ecosystem active right beneath our boots, a tiny drama playing out in the cold. Thaw versus slush. Language distinguishes the stages of melting. Thaw is the verb, the action of the temperature rising. Slush is the noun, the physical result. Slush is a suspension of ice crystals in liquid water. It is a fascinating material. It behaves like a non-Newtonian fluid. It flows like water, but crunches like ice. Imagine the sound of tires driving through slush. That distinctive shh, splotch noise. It is the sound of the season changing. Slush is the messy gray transition between the purity of winter and the rebirth of spring. It is the ugly chrysalis of the season. Whiteout causes vertigo. In a severe blizzard or on a flat polar ice sheet, you can experience a whiteout. This isn't just poor visibility. It is the complete erasure of contrast. The sky is white clouds and the ground is white snow. The horizon line disappears. Without a horizon, the human inner ear gets confused. You lose your sense of up and down. People in whiteouts have been known to fall over while standing still or walk in circles thinking they are going straight. Imagine floating in a bottle of milk. There are no shadows to tell you where the ground is. It is a sensory deprivation tank created by nature, a terrifying void of pure light. Sun cups are sculpted bowls. On high glaciers in the summer, the sun creates strange patterns called sun cups. These are hexagonal bowl-shaped depressions in the snow, often a foot wide. They form because of imperfections in the surface. Once a small dip forms, it traps heat, melting faster than the ridges, deepening the cup. Imagine hiking across a field that looks like a giant honeycomb made of ice. You have to step from ridge to ridge. It is the sun acting as a chisel, carving the snow into a geometric pattern of melting. It can snow at 40 degrees. We assume snow only falls at 32 degrees, 0 Celsius, or below. But it can snow when the ground temperature is as high as 40 degrees, 4 Celsius, provided the air is very dry. As the snowflake falls into the warm air, it begins to melt. This melting absorbs latent heat, cooling the air immediately around the flake. If the flake falls fast enough, it creates its own tiny bubble of freezing air that protects it all the way to the ground. Imagine the snowflake fighting for its life, wrapping itself in a shield of cold to survive the journey through the warm valley. Snow is heavy enough to break buildings. The weight of snow is deceptive. Fresh powder is light, but wet, packed snow can weigh 20 pounds per cubic foot. A roof covering a modest home might have to support 20 to 30 tons of snow after a heavy winter. Imagine a small house carrying a herd of elephants on its back. This static load is a constant test for architects. In snow country, roofs are steep and made of metal to shed the load. The architecture of the mountains, the A-frame cabin. the chalet, is dictated entirely by the weight of the snow. The shape of our shelter is a response to the weather. Falling snow cleans the air. Have you ever noticed how fresh the air smells after a snowstorm? That is because the falling flakes act as a scrubber. The intricate arms of the snowflakes trap dust, soot, and pollutants floating in the atmosphere and bring them to the ground. This is why snow near a highway turns gray so fast. It is holding on to the dirt it pulled out of the air. Imagine the storm as a giant filter washing the sky. The world feels cleaner because it is cleaner. The snow sacrifices its own purity to clarify the atmosphere. Fernification takes decades. How does a fluffy snowflake become a blue glacier? The process is called fernification. It is a slow metamorphosis. First, the delicate points of the star break off. Then, the crystals become rounded grains, fern. Then, the weight of new snow on top squeezes the grains together, fusing them into solid ice. In Antarctica, this process can take 100 years. In the wetter Alps, it might take 10 years. Imagine a snowflake falling today. It might not become true glacier ice until the year 2125. It is a long, slow slumber, a hibernation that turns weather into geology. Hygge is the psychology of snow. The Danish concept of hygge, pronounced hygge, is difficult to translate, but it means a mood of coziness and comfortable conviviality. It is deeply linked to snow. You cannot have true hygge without the contrast of the cold outside. The worse the weather is, the harder the wind blows and the deeper the snow piles up, the cozier the candlelit room feels. Imagine the snow pressing against the window. It defines the warmth inside. The snow forces us to slow down, to stay home, to wrap ourselves in blankets. It creates the physical boundary that allows us to feel safe. Snow reflects sound upward. We talked about snow absorbing sound, but it also refracts it. During a temperature inversion, common in snowy conditions where the ground is colder than the air above, sound waves can bend. Sometimes you can hear a train whistle or a church bell from miles away with startling clarity while noises nearby are muffled. But usually, the snow curves sound upward, into the sky. This is why thunder is rarely heard in winter. The sound is bent away from our ears. Imagine the landscape directing the noise of the world up into the clouds, leaving the ground in a bubble of silence. Bison use their heads as plows. The American bison is built for snow. Unlike cattle, which will starve in deep drifts, the bison has massive shoulder muscles and a huge, low-hung head. It uses its head as a snowplow, swinging it side to side to clear away feet of snow to reach the grass beneath. Imagine a beast moving through a white sea, parting the waves with its own body. They face into the blizzard rather than turning away. They are designed to conquer the winter through brute force. Polar bears have non-slip shoes. The polar bear is the king of the ice. To walk on slippery frozen seals without falling, they have evolved special feet. Their paws are massive, up to 12 inches wide, acting as snowshoes. But on the bottom, their pads are covered in small, soft bumps called papilla. These act like the tread on a winter tire, gripping the ice friction. They also have fur between their toes. Imagine walking barefoot on ice and never slipping. Every step is secure. They are perfectly engineered for a world with zero friction. Orchids grow under the snow. In the forests of the northern hemisphere, the calypso orchid, or fairy slipper, begins its growth cycle in late winter, underneath the snowpack. It uses the stable temperature under the snow to develop its roots and shoots, ready to burst forth the moment the melt begins. Imagine a delicate pink flower waiting in the dark, protected by the ice. It reminds us that winter is not dead. It is a gestation period. The beauty of spring is being prepared right now. Hidden beneath the cold, white surface, snow smells like ozone. Can you smell snow coming? Many people say yes. Science suggests they are smelling a combination of things. Cold air suppresses odors, making the world smell clean. But approaching storms also bring ozone from the upper atmosphere down to the ground, which has a metallic, electrical scent, and humidity rises. Imagine the smell of wet rocks, electricity, and cold dust. That is the perfume of the blizzard. It is the scent of the atmosphere descending to touch the earth. Snort is the ugly end. In the spring, when the snowbanks along the road are melting, they turn into a mixture of snow and dirt. In the Midwest, they have a word for this: snort. It is the ugly, lingering end of winter. Imagine the beautiful white drifts reduced to piles of gray sludge. It is a reminder that nothing stays pure forever. The snow interacts with the world. It picks up the debris of our lives, and eventually, it must melt away to reveal the green grass it protected. A septillion flakes fall. Mathematicians have tried to estimate the number of snowflakes that fall on Earth in a typical year. The number is roughly 1 septillion. That is a 1 followed by 24 zeros. Imagine a number so big it is meaningless. Each one of those septillion flakes is a unique crystal, a tiny masterpiece of physics that existed for a few minutes and then vanished. It is a staggering display of abundance. Nature does not ration beauty. It pours it out in impossible quantities, regardless of whether anyone is there to see it. Snow is the power of softness. We end with a thought. Snow is soft. You can crush it in your hand. It yields to your step. Yet, it is one of the most powerful forces on Earth. It shuts down airports, closes schools, and carves glaciers through mountains. Imagine the paradox. Millions of soft, fragile things combining to stop the hard, busy machinery of the world. It reminds us that softness, when accumulated, is unstoppable. It forces us to pause. It covers the scars of the land in a clean white sheet, offering us a blank page. Every snowfall is a chance to see the world made new again. And so, dear listener, our journey through the silence of snow comes to a close. We have traveled from the microscopic birth of a crystal on a speck of dust to the thunderous descent of an avalanche in the high mountains. We have seen how snow paints the world in white, silencing the noise of our cities and insulating the life of the soil. We have marveled at the blue ice of glaciers, the pink snow of the high peaks, and the diamond dust of the polar night. We have learned that the winter is not empty. It is full of geometry, history, and hidden life. From the monkey making a snowball to the ptarmigan changing its feathers, the world adapts to the cold in beautiful ways. The snow reminds us to slow down. It forces us to seek warmth, to find comfort in the quiet, and to appreciate the beauty of things that are temporary. As you lie here now, let the image of a falling snow settle in your mind. Picture a dark night, the air crisp and cold. Outside your window, the flakes are drifting down, millions of them, stacking softly on the branches of the trees. The world is turning white and silent. You are safe inside, wrapped in warmth. The storm is a gentle blanket covering the earth, tucking it in for a long winter's nap. Let your breathing slow down, matching the leisurely pace of the falling snow. Gentle, quiet, steady. You are drifting into the deep, peaceful white. The noise is gone.